So guys, welcome to the Data Science Fast Track course. My name is Nawaz. I'm a corporate trainer, consultant and mentor at InfoSec Train. So let us start with our today's topics. Okay, this is about me. We already discussed about it. So let's go further with the agenda of the day 3 or the today's agenda. So in the today's agenda, we'll be talking about regression analysis. What is regression analysis? Then we'll be talking about simple linear regression. Okay, how you can evaluate the model and how we can select the model by using the different model evaluation matrices. Okay, then we'll be talking about multiple linear regression. We'll see the what is the difference between multiple linear regression as and the simple linear regression. Okay, then we'll be talking about the regularization techniques such as ridge regression and lasso regression, and we also talk about the why we are using this ridge and lasso regression. And after that, finally, okay, last but not least, we'll be talking about model evaluation matrices like R square, mean square error, mean absolute error, as well as we have the RMSE, as well as we have the different evaluation matrices that we are gonna discuss in the last when we are dealing with the model evaluation criteria. Okay, sounds good, guys. So guys, okay, I'm giving you one suggestion. Okay, along with those codes, you can start exploring the deeper into that particular topic. Okay, as we said in the previous sessions, okay, we took the two previous session, and in those two session, okay, we were talking about the basics of Python, right? So we started with the different data types of Python. Okay, then we just started with the the different how you can create data frame in Python by using pandas library, and how you can use a NumPy library in that. And one more thing, guys, this is the beginning of machine learning algorithm, because if you understand the machine learning, so you will find that in the machine learning, okay, machine learning is nothing but we are trying to automate the machine works. Okay, like we are trying to say that, okay, like if machine is not able to do the the work like humans, okay, so or in short the automation, so we are just by providing the data, we are saying to the machine that this is the data. Now we just created the model, and that model suggests the machine, now you can do this thing, now you can do this thing, right? So over here you can see that, okay, first topic is nothing but the regression analysis. So regression analysis, you will see that there is one topic in machine learning, okay, and you will find that that topic, okay, particular topic is nothing but the prediction of numerical data. So what is prediction of numerical data? In that you will have to build the models of regression. Okay, and that is also nothing but a regression problem, right? So that is what we are gonna see in the today's session. Okay, so guys, let us go ahead and understand how the regression works. So for that we need to understand the scatter plot. Let me show you that thing. Okay, if you know, so I already shared this thing with you. Now see, yesterday, okay, what we did, I show you this particular scatter plot. Not this, we also show you this multiple scatter plot. Let me show you again. Okay, so you can understand. Import pandas for that as PD, right? Let me go and run this. Okay, this is how the data looks like. Okay, and now instead of this, let me use the population. Okay, life expectancy versus population. Let me run this, and here you go. Let's understood this. Okay, let's understand this, how you can build the how you can get the scatter plot from this. So as yesterday, as I discussed with you, so here you can see this is nothing but the one of the scatter plot. Okay, the data is totally random, that's why you can see that the few data is a lot of data merge over here, okay, concentrate over here, right? And the only few data is look like this. Okay, now let me show you the data which will be using in the today's session. Okay, okay, leave this particular by saving this particular file, and let us go with our today's code. Okay, this is not the code, this is the data that we are gonna use. Okay, let me create the one Jupyter notebook file over here, because I'll show you the how you can read the data, how you can do all the things with the data from scratch. That's why, okay, I just created the new notebook over here. Let's say this is a day 3. Okay, and in the day 3 we will be talking about the regression analysis, right? Now guys, here you can see, like as I showed you the scatter plot, which is totally different because that is coming from a real life data set. So here as well you can see that if you are creating a scatter plot, okay, so okay, how many variables we need to create the scatter plot? First, there are two variables you will need to create a scatter plot. First variable you can plot on the either x or y coordinate, and second variable you can put on the again either x or y coordinate. So here this is my variable a, this is my variable b. Okay, and you will see that the data set like this. Okay, these dots are nothing but the data points. Okay, these dots are nothing but the data points. Okay, now here you can see that, okay, I mentioned the points over here, and you will always find that, okay, when you are dealing with the real life data set, so here you will find that the outliers m- you know may present in your data set. Okay, now as I told you in the previous session, what is outlier? Outlier are nothing but the extreme values. Okay, and what is extreme value? Let's say you have the data from 1 to 100. Okay, and in that particular data, okay, there is one or two or few values are more than, let's say, 200. Okay, few values are nothing but the 200. Normal range of your data is 1 to 100, but there are only few values, let's say 4 or 5 values are there, and those values are are nothing but the 200. Okay, like the 200, 201, 202, like this. Okay, so those values are nothing but the outliers. Okay, those value are nothing but the outlier in one dimension. Now here you can see in this particular data, here you can see, okay, see, this is my data point, this is my first data point. Here you can see, and the x coordinate value of this particular data point is nothing but around 1.5, right? And for this as well, this is also 1.5, right? But for this outlier, this particular data point, here you can see the x coordinates value is going to be, let's say, 1.5, but for y coordinate you will see that the value is around 12. Okay, which means that this data is an outlier. Okay, for this particular normal range data set. Okay, this is a normal range, I would say. Okay, common range, and this is nothing but the outlier value. Okay, that is how you can detect the outliers. Okay, now here you can see, okay, I just draw the line, okay, in between the data. Okay, and that line is nothing but the line of best fit. Why I'm telling you this line of best fit? Because here you can see that this line is exactly going from the middle of these data points. That's why, okay, I showing you this particular line is nothing but the line of best fit. Okay, line of best fit. Okay, now let's move to the different types of the scatter plot. Okay, let's understand what are the different types are there of the scatter plot. Okay, as I as you show over here, okay, as you see over here, okay, how many different types are there of scatter plot? You will find that, okay, this first type is there. Okay, you can say that this is nothing but the positive correlation between your variable x and variable y, or variable a or variable b in short. Okay, so how you can identify this is positive correlation? Okay, there is some positive correlation between your both variable x and y. Okay, because here you can see as x values are increasing, in the same way y values are also increasing. That's why you will see that the, it is, these data points are making 45 degree of angle. Okay, okay, of the, okay, with the x coordinate as well as the y coordinate. Okay, so I can show you that, okay, this particular data points showing a positive correlation, because as x increases y also increases, right? Now second thing is that the, if the x values are increasing but y values are decreasing, that's why you can say that this is going to be the negative correlation, or you can simply say the trend of the data points are in the downward direction. That's why you can say this is nothing but the negative correlation between the variable x and variable y. Understood? Okay, now here this is the third type which I am saying you, which is nothing but the null correlation, which means there is no correlation. Okay, if your data points are showing a parallel correlation or parallel relationship between your, okay, with the x coordinate, so you can simply say there is no correlationship. Okay, which means that as x values are increasing but y values are constant. Okay, if you draw the line in the exactly middle of this particular data point, so you can see that this particular line will be, okay, very much parallel to this particular x coordinate. Yeah, will be like, I'm coming to this particular correlation. Okay, so firstly understand this particular topic. Okay, then we'll move to the correlation one. Okay, here you can see, okay, the positive correlation is there, negative correlation is there, and no correlation is there. Okay, if now the second thing, okay, second way to see the data, if your data points will, showing a exact, straight line, either upward trend, either downward trend. Okay, but it will show you the straight line. Okay, the pattern for your data points will be in a straight line, so you can say that your data follows a linearity, or your data is linear in short. Okay, if your data showing some non-linear, visuals, so you can say that, okay, if your data looks like this, okay, so this is nothing but the exponential. Okay, so sometimes if you draw the plot of e raised to x, okay, if you draw the plot of e raised to x and x values are nothing but 1 2 3 4 5 6 up to so on, right? So you draw this e raised to x plot, then your plot looks like this, e raised to x, okay, like this. See, like this. So this is nothing but the exponential. Okay, if your data point showing a non-linear curve also, you can say that the this shape or u-shaped curve, so you can simply say it is a u-shaped curve it is showing. Okay, now when we are talking about the linear correlation or linear relationship, okay, at that time we'll be talking about the correlation term. Okay, correlation is totally depends on the linearity of your data, right? If there is a positive relationship, or the, if your data point showing a upward trend like this, so I can say that the data points, okay, are nothing but the positive correlated, right? If your data point showing a downward relationship in a linear manner, then I can say you that these data points will be negatively correlated, right? Now these are just the type. Now what about the strength of the, how you can measure the strength of the correlation? So here if you see the structure or the pattern of your data points, okay, will be in a straight line. One also think that these data points are very much concentrated, okay, or very much close to each other, right? These data points are very much close to this other. Okay, so after, okay, if you see these data points, okay, if there are a lot of data points, so you will see that exactly, there is very few different, very less different between the data points, and they are making a straight line. Okay, they will be in a straight line. So that's why you can say that there is a strong positive correlationship. Okay, when you are saying strong positive correlationship, when your data showing a linear pattern, also the upward pattern, okay, they are going in a upward direction. So that is nothing but the strong positive correlation, right? Then what about next? So here you can see that again these data points, okay, going in a upward direction, but here you can see that the data points are very much scattered, right? These data points are very much scattered. So we can say that yes, there is a positive correlation because the data is going in a upward direction, right? But here you can see that, okay, there is a some scatterness present. So that's why you can see that this, okay, data showing a weak positive correlation. Understood? And if your data point showing no trend, okay, no pattern, at that time you can say that there is no correlation. In simple words, there is no pattern in the data set, or you can simply say that there is no correlation. Okay, understood? This is the simple thing. And okay, as we discuss about the scatter plot and correlation, okay, correlation is nothing but the, just it is finding out the linear relationship. Okay, not just the relationship, it is finding out the linear relationship. Let's say if this is the, if I am saying you this is a, this is a positive correlation, so that this particular statement is not correct. This is not showing a positive correlation, it is showing a positive relationship. Okay, because here you can see that the data points are going in a non-linear pattern, right, in the upward trend, but they are showing a non-linear pattern. So I can say you that this is just the relationship, not the correlation. Correlation is there when there is a linear relationship. Okay, when there is a linear relationship. And guys, why I'm, using this concentrated words, okay, the linear, the correlation, because you will see that in the regression analysis there is one algorithm which is nothing but the simple linear regression. Okay, in the word you, in this particular, simple linear regression, you will find that the linear word is there. Okay, and with the help of linear, so you will find that there are multiple assumptions of regression analysis are there. Okay, there are multiple assumptions of regression analysis are there. So how many different assumptions are there? Let me show you. Let us talk about the assumptions of regression analysis, or in the, I am mentioning this particular term over here, the, let's say, linear regression. Why linear regression? When if you are assuming that there is a linear relationship, then only you can go with those assumptions, otherwise these assumptions will not be valid. Okay, okay, let me correct yourself. There are total 4 assumptions. Okay, starting with, okay, if you try to, remember this, there is a trick to remember the assumption by using this particular the word which is nothing but the line. Okay, when I'm completing my master degree, my, my teachers used to tell us this particular word to, remember or memorize the assumptions of regression analysis, which is nothing but linear regression analysis. So first one is L. Okay, L is nothing but the your model, okay, is, showing the linearity pattern. Okay, linearity pattern, like someone who mentioned, okay, like the y equal to mx plus c. So linearity pattern. So you will find that y equal to mx plus c. So what is this? This is a simple linear regression equation. Also, this equation is nothing but the equation of line. So c equal to, c is not slope. Okay, yes, c is intercept. Yes, and m equal to slope. Okay, so this is going to be the pattern. Okay, now here what I wanted to say is linearity pattern. So what is linearity pattern? Here, did you see any square or any cube? Which means that there is no order, there is only one order, like m x raised to 1 is there, right? Again, if I use another equation, which is nothing but the y equal to beta naught plus beta 1 x, okay, plus epsilon. Okay, this is going to be the perfect, equation for the regression. Now why I'm saying this perfect, because this is nothing but the equation of line. Okay, this is just the equation of line. You will see that the data points are this. Okay, but in real life you will find that the the error is present. Okay, this is my data point and this is my line. So here you will find that between this, the distance between this data point and this line is nothing but the error present, right? So this particular thing is nothing but the error. So here you can see that beta naught is going to be your intercept, and secondly beta 1 is going to be the slope. Okay, now here I just wanted to tell you one thing. Okay, why I'm showing you this, guys? Okay, because if you understand this concept, then it will be very easy to understand this all equation. Okay, because this is just the simple linear regression equation. If we're talking about the multiple linear regression, so you will find that multiple linear regression equation is like this: beta naught plus beta 1 x plus beta 2 x plus up to so on. This is x2, this is x1, up to so on, plus beta n xn. Okay, this is going to be the equation of multiple linear regression. Yes. Okay, so let me repeat this again. Okay, this is a simple linear regression equal to equation y equal to beta naught plus beta 1 x plus epsilon. Why I am adding epsilon over here? Because here you can see that in the data points, okay, if you created the equation of line between these data points, so you will find that this particular data point and the distance between this line and this particular data point is, there is some distance, right? So this particular distance is nothing but your error. Okay, this particular distance is nothing but your error. Okay, so why I am saying this particular distance is error? Because with the help of regression line, what you are saying that in the future, okay, you are trying to predict the future data points. Let's say, okay, let's say this is, okay, this is the cells. Okay, this is the cells of the, let's say, month of Jan. Okay, let us assume that, okay, sales is increasing exponentially, right? Now this is the fab, this is the sales of fab. In the same way you will find that this is going to be the sales of March, and now I just wanted to predict the sales of April, right? So let's say, okay, I don't have the April's because currently it's March, right? Because currently it's March. Now let's assume that there is a data, say March data point is there, and now, okay, like previously whole, let's say we have the 10 years of data, we have the 10 years of data, right? So we have the all months of data. okay, of previous 10 years. Okay, now by using those 10 years of data, I just wanted to make the prediction of the sales of my upcoming month, which is nothing but April month. Okay, this much data you have. Now you created the model like this. Okay, now your model, let's say y equal to beta naught. Okay, let's assume that beta naught plus beta 1 x is there. Okay, and now you just estimated na, so that's why there is no error, because you just created the model. Okay, and now this is the estimation. Okay, you know this value, you know this value. If you don't know this value, so you can simply add the error parameter. If you know this value, let's say my beta naught is 1. Okay, y equal to 1 plus 3 into x. Okay, my intercept is 1, beta 1 is 3, and this is my equation of predicting the sales of my upcoming months. What I am doing over here, okay, again I am, now as someone mentions, okay, for predicting the sales data, from predicting, this is nothing but the sales. Okay, but for make the prediction of the sales data, we need to find out the few features for that. And what are those features? Those features are nothing but the x. Okay, let's say my marketing. Okay, my marketing spend, right? Then what about next? Okay, then employees performance. Okay, like that. So if your marketing spend is increasing, so which means that, okay, it will affect your sales, right? Let's say, let's take an example of Red Bull. Like Red Bull is around, like he is, like Red Bull is spending around, 45 to 50 percentage of his revenue in the marketing. That's why you will find that the sales of the Red Bull is increasing, okay, exponentially, right? So you just depending upon the some features which are there, okay, like the marketing expenses and all. Okay, you now you have that. Okay, you already know how, okay, how much marketing spend you are doing on in the April month. Okay, so you have this data, but you don't have this, so you have to predict the sale. So you can simply use this. Let's say my marketing sales is, let's say, 2. Okay, so 2 in 1,000 crores. Okay, let's say 2 in 1,000 crores. So y hat equal to 1 plus 3 into 2. Okay, so you will find that this is the thing. Okay, so your estimated value of the sales, okay, in the April month is going to be the 7. Okay, and let's say in 1,000 crore, so which means that 7,000 crores in the April month, which is the sales. And that is just the prediction, that is not the exact amount. This is just the prediction. Okay, it may be like 90% or 95% correct, right? So this is nothing but the goal of the regression. Okay, so where were we? Okay, we were talking about the assumptions of regression, right? So first assumption is going to be the linearity pattern is there, right? Then second one is nothing but the I is nothing but, this is not constant value. You will find that for each and every data set, okay, the value of beta naught and beta 1 will be changing, right? Now let us move to our assumptions of the linear regression. Okay, so second one is nothing but the I. Okay, I is nothing but the, our data, our x features. You will find that this x features. Okay, okay, so now what about next? I is nothing but the, you know our independent variables. Okay, the our variables, this variable should be independently distributed. Okay, independent variables will be there, right? Then what about next? Third one is going to be the n. Okay, now like I mentioned the epsilon over here, so which is nothing but the error. Okay, error is nothing but the distance between your original data point and your predicted data points, which means the regression line. Okay, so that particular error should follows the normality with mean 0 and your variance sigma square. So this is going to be the constant in each and every case. This will be the different. As I told you, the normal distribution is the continuous distribution in the yesterday's session. So because see guys, okay, this distribution is very much important when we are dealing with this regression analysis. Okay, right? There is one assumption for epsilon, which is nothing but the epsilon should follow the normal distribution with mean 0 and standard deviation sigma, or the variance sigma square. Okay, now the fourth assumption is going to be the E. Okay, now E is stands for the, your error is nothing but the IID normal distribution, which means that you will find that the, this particular normal distribution, okay, there is no single error, because you will find that in between each and every data point you will find that there is a distance, right, for each and every data point. So these data points, it not just the, this error is not just the single error. Okay, there are epsilon I from 1 to n, right? How, if let's suppose there are n values, n data point, that's why I from 1 to n. So you will find that the IID random variables. Okay, and one more thing, as I mentioned, this is nothing but the constant. Okay, constant in each and every case will be different. Okay, so E stands for, okay, this equally variance. Okay, this variance is nothing but the equal for all the epsilons. Okay, constant for this, right? So these are nothing but the four assumptions of the linear regression analysis. Okay, so let us go ahead and understand the simple linear regression now. Okay, understood the assumptions, so let us discuss about these things. E is nothing but the error. Now what is error? Here you can see that the error term is there. Error term is nothing but the error, the E value. And what is E? So E is nothing but the distance between your original data point and your predicted data point. Okay, we'll be talking about what is predicted data points when we are dealing with the practicals. Okay, at that time you will understand 100%. Okay, this line is not just the line, you will find that, okay, this line, okay, is just making the predictions about each and every data points over here. Okay, so there is a distance between your original data points and your predicted data points, right? Here what I'm trying to say you is that, okay, if the value of your independent variable is 0, okay, so at that time what will be the value of y, what will be the cells? Okay, so cells will be the beta naught value, the initial beta naught value, I can say, or the initial value of your target variable or the cells. Okay, if we're talking about, okay, the slope. Now what is slope? So you can see that this is nothing but the rate of change. Now this is the rate of change of y, with respect to x. Okay, as you know, if x is changing, which means that y is also changing. So the beta naught value is nothing but the range of change of, rate of change of y with respect to x. Okay, so we'll go with the practical, then you will understand these all the things. Okay, go with our practicals and understand how you can implement the linear regression in our data set. Okay, so here we will be talking about the first simple linear regression. Okay, and in the simple linear regression, okay, we'll be taking one. Okay, here you will get the data set. Let me show you that. So that's what I'm telling now. Okay, intercept beta naught value is showing the, that particular, the, the estimated coefficient in the regression line, which is nothing but the y equal to beta naught plus beta 1 x, right? So beta naught is nothing but your intercept, right? So in simple linear regression, Okay, I'll show you again in the practicals as well, then you will understand. Okay, here you can see that we have the two data points. Okay, two columns are nothing but, first one is nothing but the waist circumference, and second one is nothing but the AT is nothing but the adipose tissue data. Adipose tissue data is nothing but, you will find that, okay, around your waist. Okay, like there will be fat for few people, not all. Okay, for few you will find that the obesity, okay, or the waist. Okay, at the waist you will find that the there is fat, some fat. Okay, so which means that, okay, if we go ahead, okay, and find out the, the, if we measure the waist circumference, okay, so with the help of that, can we able to predict the AT tissues? Okay, AT tissues are nothing but the adipose tissues. Okay, so adipose tissue data is nothing but, okay, we can able to, okay, check that, okay, like depends on the, some percentage of that particular fat of the, around the waist. Okay, we can say that the, chances of the heart attack failure, right? So to avoid that, okay, we can use this particular regression model. Okay, because you will find that there is an alternative thing you can do. Okay, you, if you don't want to go with this regression, you can go with the CT scan. Okay, let's say if someone has a waist circumference, obesity problem is there, some fat is there. Okay, and like he just wanted to check the adipose tissue area. So on the basis of that AT area, okay, doctors can able to get the, the how much chances are there, okay, of getting a, heart failure or heart attack in short, right? So there is one alternative to this, which is nothing but the CT scan. But in the CT scan you will find that CT scan is expensive. Okay, if you use this regression model, this is free. Okay, if you create this model and if you made it, if you make the publicly available to this particular model, so this model will be free for all, right? Like if you just download, upload this model on GitHub or create one, Flask app for this or Heroku app. Okay, so those apps will be free to use, right? There is no charges for that. So okay, if you compare with the CT scan, which means that, right, it's good. Okay, second thing is that in the CT scan you will find that there is radiation. Okay, in one CT scan you will find that the radiation of equal to around, 400 to 500 x-rays. Okay, if you just go for the x-rays and if you, do your x-ray of chest x-ray, and if you go for the same and you wanted to do the CT scan of your chest, so the CT scan machine, okay, will produce the 400 or 500 times more radiation than the X-ray machine, right? Which means that there is a one again chance of, having the cancer. Okay, because with the radiation you will find that, okay, some people are facing the, cancer problem. Okay, that is again the second big issue. So if you wanna, reduce that particular issue, or you don't want to go with that particular scenario, so you can use this particular regression model. Here what I'm trying to say, that I'm trying to understanding you, like instead of doing these several alternative things, okay, you have the free and the safest option, right? So you can even go with this. Okay, and you will find that there will be a, the, 90% possibility is there for this particular predictions. Okay, let's say if someone, okay, come to me and say that my waist circumference is this much, I just wanted to find out the AT area, adipose tissue area. So I'll simply use this particular model and I'll tell you that this is your AT area. Okay, so this is nothing but the, without any cost, okay, he got the, the, 90% or 95% accurate result of his AT area, right? Another one name is what, Heroku is there. Okay, you can use Heroku as well. Okay, and there are the cloud platforms as well, which are publicly available, but those are the paid one, like the AWS is there. You can deploy your model over there. There is a Azure is there, there is a GCP is there, Google Cloud Platform is there, right? So you can use these platforms as well to deploy your model, okay, with a very less pay, right? Or simply you can use a Flask. Okay, like at the end of this particular course, I'll try to show you the the one end-to-end data science project with the deployment in the Flask app. So you will understand how you can deploy any other machine learning model in the Flask, and you can create your own Flask app. Okay, so let's come to our topic. And here you can see, guys, okay, we have the only two columns now. Okay, and that dimension of this is going to be the 109 multiplied by 2. Okay, which means that first row is just the column name, that's why 109 cross 2. So 109 rows are there and only two columns are there. Flask is a library in Python. With the help of that, you can create a web page, right? You can create a web page. If you create a web page which is looks like the app, so which means that nowadays if you are using, let's say, Instagram or Facebook, okay, this also the Instagram were built by using Python, right? So you can create your app as well by using Python as well. So there are few libraries, let's say like Flask and all, so those are providing you to create the web page in Python itself, right? There is only few line of code you can create. You can create a structure of your head and body, right, in HTML and CSS by using those two tools, and simply you can use that particular code over here and you can use your ML model in that. So Flask will help you in that. Now for deploying that, okay, I'll need to create the HTML or CSS code as well, right? Few lines of code, just the basic, not the extreme one, just the basic one. Okay, so it will take more time. So right now, okay, I'll be showing you how you can create your ML model. Okay, after understanding how you are creating your ML model by using multiple ML algorithms, like the starting with the regression analysis, then we have the few classification projects as well. Then at that time we'll be using classification algorithms. So around around 15 to 20 or 25 algorithms are there in the machine learning. So you can use those algorithm first. Okay, you can get your hand dirty so over there, hands on with that, and then we can go ahead with the Flask. Okay, so it will be easy to understand each and every topic, right? So let us go ahead and just deploy or the read the data set in the Jupyter notebook. Now how to read the data set, guys, in the Jupyter notebook? Now before that, what are the different libraries I need to the import? So these three libraries are very much important. Okay, so first let's go and import these three libraries by using the import command. Import pandas as PD. Instead of using pandas, I'll be using PDs now. Then I'll be importing numpy as NP. Then what about third? Import matplotlib dot pyplot. Pyplot is a module in the matplotlib, and with the help of that you can create the multiple plots, okay, in a with the one line of code, right? So let's go and execute this cell by using, either you can simply go and run this, or you can use the shift plus enter, or you can use the control plus enter. There are multiple ways to run this. Okay, and if you are using a desktop, so I guess F5 will be there. If you just press the F5, I guess not for this, but for the in the spider, if you are trying to if you are using spider or I guess for PyCharm as well, then you can use the F5 as well. Okay, but there is a condition if you are using the desktop, then only. Like when I was using the desktop, so at that time I used to just F1, by just pressing the F1, which means that the code will be executed. So now after this, let's go and import the data set, and this is my data set WC80. So let's read that data by using, let's say, df, or you can use any name. You can simply use the WC80 as well, okay, to understand this data. Okay, so first thing, as we know, we are going to read the data. PD dot read, sorry, read underscore CSV is there, and in the in the bracket you will have to add the path. Okay, but okay, let me tell you one shortcut in the Jupyter notebook. Okay, like if you have the data in the same folder that your notebook is, see, this is my notebook. Okay, this is my day 3 regression analysis .ipynb notebook is there, right? So in the same folder I have my data set. Okay, so you don't have to write the the path of the folder, okay, path of your data set, like this. You don't have to write this, just use your name and the format, like the, let me show you. Okay, wc dash at dot csv, just use this much. Okay, just this much, nothing else. Okay, and enter it, and here you can see the your data set wc80. Okay, if your data is in the same folder that your you know this particular your notebook file is, okay, then you can use this thing, right? Now this is my data. Now guys, you can see that the how many rows are there in the data set? 109. How many columns are there? Two columns are there, right? Two columns are there. Now, okay, let me add the aim of my this particular project. Okay, this is a short project, mini project, I can say. Okay, so for that, let me add the aim for this. Aim for this. So the aim of this, okay, is to study how well waste. So guys, let us go ahead and go with our code. Like as we know, we don't want to see this much data, because you will see that in the in between you will see that the three dots, which means that okay, it is not showing me the whole data. So what can I do? Okay, I can simply use the wc80, okay, dot head, okay, to see the sample data. I just wanted to see the top 5 rows of my data. Okay, if you don't want to see the top 5 rows, no issue. You can, if you wanted to see the last 5 rows, okay, you can use the tail method and control plus enter, and here you can see the last 5 rows. See, now again, if you don't want to see the last 5 rows, you can go and use the sample. If you wanted to see the random data and how many random rows you want to see, let's say 7 rows I just want to see, which are totally random, so you will get the random data you can able to see over here. Okay, this is the thing you can do in Python. Okay, which means that for doing one thing, okay, there are multiple options we have, right? There are multiple options we have. Okay, so you can use those options if you know the multiple option for doing the same thing. So it will be very easy to create your own code. Let's say I just wanted to check the shape of the data. Okay, this is for our understanding, guys. Okay, this is for our understanding. Here in the first, you will find that just by using the data, okay, we got the data. But what if our data in millions? Okay, so at that time, if you run this data, which means that, okay, you will have to scroll for some minutes. Okay, otherwise you will have to just do this thing. Okay, so you will see like this. Okay, see this thing. Okay, if you click to this, okay, if your data is quite big, so you can do this thing as well, but again you will have to scroll down na. Okay, so if you are not, don't do this, you can simply do one thing. You can go over here, you can use the shape. Okay, so you can simply use the shape, and actually shape is not the tuple. Okay, this is the shape is the attribute, not the function. That's why I got the error, because I added the two brackets over there. Okay, so here you can see that the how many rows are there, 109 rows are there. How many columns are there? Only two columns are there, right? Now second thing is that we have to check, is there any missing value present in our data? Yes, we will have to do this, right? So let's go and check. So how you can check, is there any missing value in your data or not? So for that, I told you, the here you can see that the backslash. Okay, like I just put it the forward slash. So here you see the backslash. Okay, and as we know in Python, backslash is reserved for the escape character. So for that you will have to one more backslash, otherwise it will throw the error, right? So I'll have to put the backslash. Okay, and let me run this, and here you can see again. Okay, I got the same output. Okay, right? Yes. Okay, you can go ahead with this. Okay, is dot, okay, is na dot sum, is na to check the missing value dot sum. Okay, so here you can see that in this particular column there is no missing value, zero missing value is there. In the same way, okay, there is no missing value present. Okay, what is another way? Okay, so you can use simply wcat dot info method and run this. Now here you can see that the how many rows are there, 109. Okay, and how many non-null values are there, 109 in both the columns, which means that there is no missing value. Okay, with the help of info method you can simply compare the how many entries are there. These are the total entries in the your data, which means total rows in the data, and you can simply use this thing. Okay, to check, you can simply compare this. If there is, let's say, 108 values are here, so we can simply say that yes, there is one missing values present in the waste. Okay, also you can use this particular code. Okay, if you are using this particular code, it will give you the the sum of the missing values that is present in your waste. So as we know, there are no missing value right now in the waste column. Yeah, we will be using the few data set in the upcoming session. Okay, those contain the missing values. Okay, initially, why we are going with this small data set? Because it will be very easy to understand the data set and the process as well that we are implementing on the data set. Right now we are implementing the regression analysis on it, right? So it will be very easy to understand. That's why I'm using this much small data set. Okay, as in the upcoming session we'll try to use the larger data set, so you can understand how you can handle that larger data set too. Okay, so this is the again the two different methods. So with that you can check this thing. Now okay, one more thing guys. Okay, let's say if you have the 1000 column. Okay, or simply let's say if you have the 100 to 100 column. So if you go with this link, okay, either you can go with this. Okay, which means that okay, each and every time it will throw you the it will give you the output. But here you can see that for that you will have to check, manually check, yes, is there any missing values or not. Okay, so at that time you can simply put the sum on this. Okay, the sum on this, so which means that you will get the sum of your missing values which are present in your overall columns. Like you put the sum on the each and every column, right? So in the same way, you can put the sum on the total all data, so you can simply get the one single values, and on the basis of one single value you can simply check yes. If the value is 0, so you can simply say yes, there is no missing value, and if the if there is some missing value, so you can say that yes, there is missing values present, right? Then you can go ahead and find out which column having a missing value. Is n is there, okay? Is null is also there, okay? I guess you can use the is null in the R, okay, or even you can use the is null in the Python as well, but okay, we are preferring to use this is na, okay. See, there are only two columns now, so it's totally like why to go ahead with that particular thing right now, okay. If there are a lot of column, let's say in the multiple linear regression, okay, there are I guess 7 8 columns, okay. At that time I'll show you how you can go and do the sum on the overall data, okay. So it will be practical thing for doing this. Now it's only two, so why to go ahead with that, right? But definitely I'll show you on the bigger columns data set. We imported the matplotlib library as plt, so I'll be using the plt dot, let's say I just wanted to create the histogram first, okay, by using the one column, okay. And how to check that column name, okay, let's say by using this, or we have the, let me add the one more you know cell over here, okay, with the help of wcat dot the columns, okay. Just use this particular attribute and you will see that the, okay, it will give list of the your column names, okay. So you can do this thing, and let's go with the first waste. So for that, again wcat dot now waste, and let's run this, and here you go, okay. Here you see this is just the beans, okay. This is just the beans, and here you can see the values for those beans, okay. So if we're talking about the x-axis, so x-axis is nothing but the different classes, as I told you the bins about the the bins in the yesterday session, okay. So these are nothing but the bins, okay. Here you can see that the from the starting point, let's say this is the starting point, let's say 60, okay. This is the first bin, 60 to 17, then 70 to 80, 80 to 90, 90 to 100, like that you will find that each bin, okay, right. And you will find that the the how many points, how many data in between these bins, okay. Then these values, this range, so that is what we are showing over here, right. Here, okay, the main thing is to don't get into the bins, okay. The main thing is to get into the different interpretations of the histogram. What is the purpose of creating histograms, okay? Let me show you, okay. As I told you yesterday, bins are nothing but, let's say we have the 1 to 100 data points, and you can see that I just created the bins, right? Okay, let's say 21 to 30 up to, you will see that the 91 to 100, see. And here you will find that how many values are there in your data which is in this particular range, in this particular range. So let's say we have the 4 values, for this we have the 5 values, for this we have the 9 values, like this, okay. So you will find that, okay, this thing, right, okay. So in the same way, here you can see this thing, okay. Here you can see this thing, right. Like in Python, it will it will create, it will select all, okay. It will do all the things automatically, you don't have to worry about it, okay. Like the bins and all, okay. Just use this particular plot and it will create this histogram for you, okay. And this histogram is a standard one, right. like by using the formula for creating the bin, how many, okay, how many bins which are, standard or the important for this particular data, like there are only 109 values are there, so how many bins we require for this. Okay, so he can automatically, do all the things and he can present you the histogram. Okay, yes. So by default it will set the bins for you. Okay, you have to worry about the interpretation, how you can do the interpretation. Okay, right? So here if we talking about the interpretation of histogram, as I told you yesterday, you can find out the range. Okay, range of your data. Like as we know, the standard range of the age column is between 0 to, let's say, 100. Okay, like our age, the human age, the standard age is between 0 to 100. 0 is newborn, 100 it's, I guess it's a, very extreme point. Okay, you know or 80, 80 is sufficient, I guess, 0 to 80, right? So that is the standard age range, right? So this is how you can say this is nothing but the range of the waist circumference, right? This is the range of the waist circumference, let's say from 60 to 120, right? Now what about next? Okay, here you can see that the distribution of this particular data is the bimodal. Bimodal because there are two spikes. Okay, this is the one, this is the second, which means that there are two modes, right? Okay, here you can't say that this is a, positively skewed and negatively skewed, because you will find that there are two spikes. Okay, that's why you can't say that it is, positively skewed or negatively skewed or a symmetric distribution. Okay, so like this you can identify few insights of your data. Okay, and that will be very important for you to understand your data, right? Like how many times, like the how many times that value repeated in the data. So see this value here, in this particular, okay, this particular bin has the highest value which are repeated in our data. Okay, so most frequent values, right? This is nothing but the mode. It there may be, single mode distribution, okay, or a bimodal like this. Okay, this is a bimodal distribution, right? Or you may got the more than three modes as well. You will find that the trimodal distribution, but that will be a very rare case, right? Now then what else you can find out? The range, the mode you can find out. Then you can find out, okay, the skewness. Skewness is nothing but the shape of your distribution, whether your data is a positively skewed or negatively skewed, or you're symmetric. Okay, like as we discussed this yesterday. Okay, so here, we got the bimodal distribution, so we can't say that yes, there is we can't say that there is a positively skewed or negatively skewed distribution or even a symmetric distribution, because this is a bimodal distribution, right? Then here, okay, we also find out the kurtosis. Kurtosis is nothing but the shape of the distribution, as one mentioned, tail. Okay, is there the, like, is the distribution which is having a long tails are nothing but these values. Okay, these values here you can see, or these values. Okay, so this is the thing, mean the end point value. Okay, either starting or ending, right? So if these values, if you see, okay, these values are present in long term. Okay, so you can say that there is a, platykatic distribution. So that is nothing but the kurtosis measurement is there. Okay, so like this, okay, you can identify few insights from your data. So again we are using the, you know same column, right? Waste column. Okay, and we are finding out the box plot. WC80 is nothing but my data set, and I'll be creating the box plot of the waste column. Now here you can see box plot. Okay, so as I told you yesterday, guys, okay, as we know, we can find out the minimum value from the box plot, right? We can find out the maximum value from the box plot, right? So we can find out the minimum and maximum value from it, right? We do not find out the average value like with the box plot. This is nothing but the Q1. Q1 is nothing but the 25th quartile, right? 25th quartile, or in simple word, you can see Q1 is there. Okay, then yes, median is there, 50%, or the second quartile, which is also known as the median. So these are the few different things we can find out. Okay, even if you go in the deeper, okay, you can find out the the whether your data distribution is the positively skewed or negatively skewed or symmetric, which means that you can even find out the skewness as well. Okay, you can even find out the skewness as well as the kurtosis. This is the 25th percent, right? This is the 50%, this is the 75th percent. Okay, this is the Q1, Q2, and Q3, right? Okay, this is the minimum, the below line. This is the maximum. Okay, these are nothing but the Q1, which is the 25th percent, right? 25th percent observation. This is the 50th percent observation, and this is the 75th percent observation, right? So I can simply use WC80 dot describe, right, and run it. And now here you go, minimum, okay, maximum value, 25th percent value, 50% value, and 75th percent value, right? And you can reach a cross check, okay, whether these values are correct or not for the west column. Okay, so this is my box plot, and these are the features. Okay, now, okay, there is one task for you. Okay, now you can do is you can just go ahead, okay, and try to find out the histogram for the AT column. For which column? AT column, and try to find out the box plot for the same column. Okay, and after finding out the box plot, okay, then try to understand where is minimum value, where is maximum value, 25th percent, 50%, and 75th percent. Okay, so that's what you can do after this particular session as well. Okay, now guys, after this, okay, as we know in the regression analysis, okay, I'll have to first understand the relationship between the the let's say the variables. Okay, so for that, yes, I'll have to create the scatter plot for this. Okay, but you know like we'll create the scatter plot as well. Okay, but we'll create the scatter plot, okay, with the regression line, right? Then you will understand this thing. Okay, so like let me create the scatter plot for your understanding. Okay, scatter, then I can simply use the as we know, my x variable is going to be the west. Okay, west circumference. So I'll simply use the WC80 dot west. Okay, and my y column is going to be the 80. So I'm gonna use the WC80 my data set, and 80 column is there, right? And let's go and run this. Now here you can see for this I'll have to see guys. Okay, when we are dealing with the understanding these things, okay, so you will have to understand this one by one. Okay, you can create this multiple, okay, you can create this thing, okay, this plot, okay, for the multiple in ones, okay, like, but you will again get the small part okay, and somewhere here you will find the another plot. Okay, I'll show you in the upcoming part, okay, when we are dealing with the large data set. Okay, so you will understand, yes, we can do that again. Okay, but if you are visualizing this particular data, okay, let's say this particular histogram, so that will be very easy to understand. Okay, if there are a lot of data, if there are a lot of plots, okay, so it's very complicated for you to just go ahead with each and every plot, right? So create one plot and understand this plot first as a beginner. Okay, then if you know this thing, okay, and then you can create the multiple plot, 9 plot in a one graph, and you can simply go ahead with your insights, right? Now this is my scatter plot. Let me show you the value of correlation, right? So there are multiple ways to find out the correlation. One way is to simple, just go ahead with the wcat.at, right, and use the core. Core is for the correlation, okay, and in bracket use again wcat, the another column, which is nothing but the waste column. You can either use the column, okay, first 80 and then waste, or you can use the first waste or 80 then. Okay, both are same. Okay, let me go and run this now. Okay, this will be the the value for this. Now let me you will see that the few very decimals value like 0.8185. Okay, so let me round this value to only 2 decimals. Okay, so for that I can simply use round, and in the end I'll have to add the how many decimals I want. Okay, for that let me zoom this. Yes, and here you can see first I use the round, and in the end you will find that I mention how many digits I want to see. Here you can see. Got it? So that's how you can go ahead with, okay, and find out the correlation. Okay, now what about any alternate method for this? Okay, so there is alternate method. With the help of this you can simply use this, okay, the numpy library, as you know. So with the help of numpy library, np dot correlation coefficient. So it is basically very influenced by the statistical professionals. So also created by the statistical professionals. So that is why you will see that in the statistics, okay, we will be talking about the correlation, okay, in terms of correlation coefficient, right? So that's why here we got the short form for this core coef. So use this core coef, and in that just use the two column names. So as we know, first column name is this because first I'll have to add mention that data so I can extract the column from that data. That's why I'm doing this thing. Okay, so this is my first. Let's go ahead and copy this from over here. Okay, or even you can type it, and let me run this. Now here what we got the array. You see that the power of np numpy. Okay, we got the array. Okay, you see that if you go and find out the correlation of this with itself, so the correlation for this is 1 with itself, the same parameter if you are using. Okay, and waste, so here you can see the correlation of 80 and waste is this much as well as this much. Okay, because okay, whether you use this term first or this term first, okay, like you will get the same output, right? As I told you over here, instead of 80 here you can use waste, and instead of waste over here you can use 80, then only you will, okay, then also you will get the same output. Okay, there is no difference in the output. So this is the term. Now guys, after understanding this term, here we got the correlation in between these two columns, which are nothing but 82 or 0.82 or 82%, I would say. So which means that yes, okay, okay, there is some kind of correlation which is more than moderate correlation. Okay, moderate positive correlation is there, but not a very less moderate. It's not a, it's somewhat which is very much tends to strong, I would say, right? Strong positive correlation, but not that much strong, because here we got the correlation is only 8 to 2, not the 90% or not a 0.9% or 95, right? So that's why here, okay, we got the correlation which is 0.82, which is between moderate or strong, which is between the moderate and strong positive correlation. Because we got the positive value, that's why we are saying positive. And also here we cross check that yes, our data is going in an upward trend, so we can say that yes, there is a positive correlation, right? Okay, now guys, let us go ahead and build the our first simple linear regression model, which is a like for many of you guys, this is your first machine learning model, I would say, right? So let's go and build that model. Okay, so it's very easy, guys. Okay, in Python you will have to add few line of code, okay, and it will create your model, nothing else. You don't have to find out the coefficients of your model, not like that. Okay, just use one line of code and it's all set. Now let's go and use the different libraries for creating the regression model. Like first I'm gonna use the stat models library, because stat models library is created by the statistics professionals, and in the name itself there is a stat models. So regression model is basically is from the stats model. Okay, this is nothing but the stats model library, guys. This is very important for the regression analysis, and believe me guys, it will give you a summary which is very much interesting, right? Which is very much interesting. So guys, let us go ahead and why we are using stats model. Okay, we are using stat model for building the regression model, guys. This value is nothing but the correlation between AT and waste, right? And the same value, this value is again the correlation between AT and waste. Okay, but you will see that numpy array mostly give you the output in terms of array, in terms of array. Okay, like I'll show you. Okay, here if you have the, let's say if you wanted to find out the correlation of x and y, okay, so by using numpy it will give you the no the correlation of, here you can see that the xx first, then correlation of xy, then correlation of yx, then correlation of yy. So as we know, there is one theorem, you can go and check it out. Okay, the value of correlation of x with itself, which is 1, the value of correlation of this y with itself is 1. So you will find that over here value is 1. Okay, the diagonal values are 1 because of this particular thing. Understood? Now the second thing is that this is a correlation which is showing that 0.82 if you round up. Okay, if you round this formula dot API, we have to go with the API. Okay, because okay, after few line of code you will understand okay why I am using stats model for building the regression analysis. Yes, is there any different library? Yes, we can use that library too as well. If okay, if we got the time at the end of the session, I'll show you how you can use any other library as well, let's say sklearn library, to create the regression model as well. Okay, I'll show you that as well. Okay, but first let us go with the stats model. Okay, so this is the stats model dot formula dot API as SMF. We are using SMF instead of stats model dot formula dot API. Understood? So let's create the model. Okay, and I'm gonna use okay the SMF dot OLS. OLS is nothing but the ordinal least square regression model, right? So I'm gonna use the OLS model, so which is one of the regression model. With the help of that you can find out the coefficients of your regression model. Okay, this is not any other thing, this is just the ordinal least square regression model. Okay, as we discuss about the regression analysis, y equal to beta naught plus beta 1 x, guys. Okay, so we are finding out the, from the data we are finding out the value of beta naught and beta 1. Okay, so with the help of OLS we are just finding out the value of beta naught and beta 1. Okay, don't worry, I'll explain this thing. Okay, after few line of code, then you will automatically understand. Okay, this thing, let me create the model. Okay, let me write the function. As we know, our aim is to, you know predict the 80 from the, which one, waste, right, from the waste column, isn't it? Right, so we just created the formula for this, and we are providing the data. And which data we are providing? The our WCAD data we have. And after that, after building the model, what we can do, we can simply fit this particular ordinal least square model, okay, to fit our regression equation. Okay, so that's it, dot fit, which means that create the model, in short. Okay, we are commanding to our system like build the model like this. Okay, which can, you know show you the formula like this is the y value, this is the x value, this is my data. Okay, and build my model, that's it. Okay, we are just commanding to my computer or to my laptop, saying that build my regression model by using this particular line. Now see, it is taking some time now, right? It is taking some time, you will see that now we got the output, right? This is x coordinate, this is y coordinate, right? So if we're talking about the y and x, so it will be very relatable for us. Okay, this is y, which means that this is my target column, and x is equal to my input feature, okay, that I'm gonna use to build the model and which can predict the 80, right? Let us go ahead, guys, and see the parameters that we find out. Okay, this is my model dot params. Okay, I'm just finding out the parameters for this. Now here you can see. Now basically I use the OLS, ordinal least square regression, to find out the intercept and waste column coefficient. Now this is nothing but, as I explained over here. Okay, over here let me show you, y equal to beta naught plus beta 1. After estimating, you will see that the y hat, which is nothing but the y estimated, equal to beta naught plus beta 1 x. Okay, now here we just find out, or we just estimated the values of intercept, which is beta naught here, and beta 1, this is the value of beta 1. Okay, with the help of OLS. OLS is one of the method, ordinal least square method, right? We just use this particular method to estimate our coefficients of regression equation. Okay, now we are ready to use our regression equation. Okay, my regression equation is ready, okay, in the form of my model. Okay, instead of using y equal to beta naught plus beta 1 x, I can simply use the model, right? Model from now. Okay, now what I can do is I can use this model for the prediction. Okay, so I'll use this model for the prediction now. So for this, let me store the predicted value as the predict. Okay, pred. I'm gonna use the model to make the prediction, okay, of my past data, okay, which is there. Beta 1 again for this particular model, this is beta naught, guys, and this is beta 1. Okay, as I mentioned earlier as well. Okay, this is beta naught, beta 1 is nothing but the, as I mentioned, beta naught is intercept, right, and beta 1 is slope, right? So beta naught is intercept, so intercept value is here. You can see intercept word is here, and the value for intercept is here. Okay, so beta naught is this and beta 1 is this. Okay, okay, guys, so let us go ahead and make the prediction by using a predict function. Okay, and I'm gonna use now ilock method. Okay, why I'm using multiple methods over here? Just to show you how you can use these methods. okay, and wherever you can you okay, like where you can use this method, right? So let me go and make the prediction. Okay, now we got the prediction. Okay, so now what I can do is I can simply build my model. Okay, which means simply, I can show you how you can, okay, how we got the, the plot. Like I show you this particular thing, okay, this particular line and dots and all, that's what I can show you over here right now. Okay, so for that, let me create a scatter plot. Okay, scatter plot. I think, I guess we just created over here. Okay, so let me just copy the scatter plot from here. Okay, it will be very easy. Okay, this is my scatter plot I just created. Okay, now the second thing is that, okay, let me go and use the plt dot plot. Why I'm showing you is this, okay, because if you see that the first thing, okay, I show you this thing, okay, the, scatter plot, and secondly I'm showing you the plot for the line, for the regression line we are creating, right? So let's go and create the regression line now. Okay, so again I'm gonna use this particular thing, paste, okay, as x, and as y I'm gonna use the predicted value. Okay, as y I'm gonna use the predicted value, right? And now here you can see, now let me use the color, which is the, let's say, different color I'm gonna use, because you will see that for the scatter, the default color for the scatter plot is going to be, blue. Okay, so I'm gonna use this color as a, let's say, red. Okay, so that will help, okay, us to, to see the line, regression line, right? Okay, now let me label it. Okay, label it like in the scatter plot. Okay, there is no label, okay, to understand what is this. Okay, like what is this axis mean and what is this. Okay, so that's why I'm gonna add the labels over here. So that's why I'm gonna use the plt again, x label, right? And in the x label we have the waste. Okay, and in the, again in the y label you will see that, y label you will see that the, adipose tissue, our 80, right? Okay, now let me go and run this. Okay, now see here I got the error, plot is not defined. Okay, so what I can do is, okay, name error is there. Okay, see plot. Okay, and now okay, here you can see that instead of plt I wrote the plot. Okay, my typo, my bad. Okay, so let me go and run this again. Again I got the error, that's cool. Okay, again here you can see, okay, I got the again error. What is it, what it is saying, plot got an unexpected keyword argument. Now let me go ahead and remove those unexpected arguments, because in the scatter plot we can add the x and y, but in the plot we can't add the x and y, we can simply add the names. Okay, so I guess, okay, this time it might work. Yeah, so now see, is it okay, we are able to the, see the regression line, we are able to see the regression line. See, so that's how you can create the model. Okay, now see the summary of the model. Now see the summary of the model. Now you can see that the summary, let me go and run, and now you can see the beautiful summary of this particular regression model. Okay, why I am saying beautiful summary, because you will see that the lot of, evaluation matrices it can provide to me. Okay, by using just the stats model library. So stats model library is very much important, guys, if you wanted to see the summary like this. Okay, and this is the only model which can give you the summary like this. Okay, this is the only summary, okay, just given by this particular library only. Yeah, and in that you will find that the, what is dependent variable over here, which is 80, which means this is my target column. Okay, I have to build a model for this particular to predict my 80 adipose tissue area, right? Okay, which model I have used? OLS, ordinal least square model. Then which method I have used? Least square method I have used. The date I have executed, this particular model on this particular Jupyter notebook. The time, number of observation over here, 109 observation, yes, in my data. Yes, degrees of residual, this is another part, because again, okay, if I go with this, the description of this, so again it will take me 15 to 20 minutes. So let's forget about this term. Okay, the df of the model, these are nothing but just the degrees of freedom. You can note it down, and you can, after the session, you can search on the internet what is degrees of freedom of the residual and what is degrees of freedom of the model, right? Then covariance time is non-robust. Okay, now after, let us go ahead and see the few evaluation matrices which are there, okay, mentioned in the the agenda. In the today's session, you can see that the r square. Now what is r square? R square is nothing but the showing you the how accurate your model is. Okay, your capability of your model, right? Adjusted r square, here r square is nothing but 0.67. 0.67 is nothing but the 67% of variation. Okay, the variation of this particular data, your AT data, explained by your waist column. Your waist column, which means you just collected the waist circumference data, isn't it? Okay, right? So after collecting this data, yes, how much this is helpful? Okay, this data give me the 67% of information for this AT column. Now what about adjusted r square? So we'll be talking about the adjusted r square, okay, when we are creating the multiple models. Okay, and we'll see which model giving me the highest r square value. Okay, if out of, let's say, 10 model I have built, and out of that model, okay, one model giving me the highest accuracy, so that is nothing but the highest adjusted r square value. So I can say that particular model is the best model to make the prediction, to make the future prediction. Accuracy is not the r square is not the accuracy of the model over here, because accuracy is somewhat different. Okay, r square is somewhat different. Okay, we'll be talking about the accuracy in classification. Okay, but in regression we'll be talking about r square most of the time. Okay, yes, how to identify? Yes, that's what I am gonna tell you. So here you can see r square value. If your r square value is 67%, which means that 67% of the time, okay, 67% information of the your AT column, your target column, is you can find out from the waist column only, right? So we can say, let's say if your r square is 90%. Okay, let's say your r square is 90%. Okay, so which means that, okay, 90% of your AT columns information, okay, which is given by the waist column. Okay, that is the thing. So guys, after this, here you can see that adjusted r square, as I told you, if you are creating multiple models, so at that time you will need to see the adjusted r square value. Okay, whichever model giving you the highest adjusted r square value, that model is you can use, that model you can pick to make the future prediction. What about f statistics? Okay, so f statistic is just the value. Okay, you just wanted to see the p value of the f statistics, which is this. Okay, and if this value is less than 0.05, okay, so there is a hypothesis test of f statistics. So okay, so in the f statistics, okay, which is saying that the null hypothesis for this is to model is significant for making upcoming predictions, and model alternative hypothesis is model is not significant for making the you know future predictions. Okay, p value is nothing but the value of the your, what I can say, your, the point, okay, from where you can decide, okay, your model is significant or not. Okay, so not the default value, you can use any p value, but most of the time we are using the p value as a 0.05. So here you can see, okay, you can see here, okay, the value is nothing but 0.00000, very less value, because e raised to minus 27 is there. Okay, which means that around 26 zeros are there before the one value. 0.26 times 0 value is there, and then 162, so which is absolutely less than 0.05. So I can say, okay, which means that, okay, I'm just accepting the null hypothesis, and null hypothesis saying that my model is significant. So guys, that is the statistical part. Okay, like that is a statistical part. Why do we wanna match the probability and hypothesis here? Because to show you that our model is significant or not for making the future prediction. Okay, how you can check your model is strong or not for making a future prediction? So by using this, you can check your model ability, right? The ability of your model, right? So that's why hypothesis testing, probability is again the very much important. Okay, if you know that, so it will be very easy to go ahead in the machine learning as well. In fact, there is one algorithm is there, okay, in the machine learning, which is nothing but the naive Bayes algorithm. You can search for this naive Bayes algorithm, you will find that that algorithm is totally based on the one theorem, which is nothing but the Bayes, and that theorem is totally based on the probability. Okay, which means probability is very much important in machine learning for creating the models. P value, okay, p value should be less than 0.05. Okay, p value should be less than 0.05, then only you can say your model is significant. Okay, now log likelihood is there. Okay, now log likelihood, AIC, BIC, these are the criteria. Akaikis information criteria is there. This is the Bayesian information criteria is there. If you wanted to you know see this criteria, and from this criteria, if you wanted to decide whether your model is strong or not, so what you can do is try to check these values, okay, are close to zero or not. Yes, my these values, if you are using building the 10 models, and you are checking the AIC, BIC or log likelihood value, so try to see these values, okay, are close to zero or not. If the any model giving you the AIC, BIC log likelihood value which is very much close to zero, so that model is, I will definitely okay, tell you that that model is 100% correct and strong model, right? So okay, these are the few statistical terms. Okay, if you wanted to explore deeper into it, so you are just free, feel free to explore more about this in on internet. Okay, or you can definitely come to me on on LinkedIn. I'll share the some resources with you, so you can explore this thing. Okay, now this is the second table. Okay, now this is the first table. From here you can decide your overall model is significant or not. Now from this second table you can decide your each and every column is significant or not, like my waste column. Okay, if you have the multiple columns, so you can say your multiple column is significant or not, right? And these are the few statistical tests. Okay, with this test you can simply check, okay, again your model's credibility. Okay, now I'm not going into it. Okay, but okay, again, because it will take so much time. Okay, so okay, these two table, first two table are very much important. T means the T distributions test. Okay, T means the T test, and this is the probability of T test, and this is showing that the probability value is zero. Okay, which means that p value is less than 0.05. So I can say this intercept is just making a significant effect, okay, on making the prediction, as well as the waste column also making a significant effect on making a prediction of upcoming data. So I can say this model is good, but again r square value is not that much good. Okay, so you can go and make the further changes in your model, and you can build the model again, because see, this is just the two columns over here. Okay, there are just the two columns over here. That's why you can, okay, we can get the r square like this. Okay, you can improve the r square by using the manipulating your independent data. Okay, again, that is a different case. If you wanted to explore more about this, like like we have the, you know, one course for that. Okay, you can check that as well. Okay, because that is again the, which is some kind of, you know, some detailed situation, I can say. Okay, so let's go ahead. And okay, this is about the simple linear regression. Okay, now let us understand. Okay, because okay, this is the, you know, base. Okay, now after, you know, this thing, if you understand this thing, so it will be very easy to understand the multiple linear regression. Okay, so let's go ahead and understand the multiple linear regression now. Data set, which is nothing but the cars data set. Okay, and as you know, we just you know, imported the all the library which are necessary to read the data, to create, you know, plot the data, you know, and all, which is nothing but we already imported this. So again, in the same Jupyter notebook, you don't have to, you know, again import this library. So you can simply go ahead and use the cars data. And as we know, and let me run this. Okay, now here you can see that my cars data. Okay, cars data dot head, and here you can see this is my car data. In the car data, you will find that the horsepower of the vehicle, okay, of the car, mpg, miles per gallon, right? This is my target column. Okay, like in the previous case, my target column was 80 adipose tissue area. Now here my target column is nothing but the mpg, okay, mile per gallon. Now here you can see that first horsepower of the vehicle, volume, okay, the space inside the vehicle, okay, then speed of the vehicle, highest speed, and the weight of the vehicle, right? Okay, now after this, let's say, and go the, you know, do the same thing as we did before. Okay, you can go with the multiple different things, but in the simple words, as we know, as we, did this thing, has, you know, as we created the model like this. Okay, we are using the same thing to create the model over here as well. So again, okay, this model is again the, you know, pre-process already clean model, because I, in the model, okay, if we sit for the, you know, data cleaning, okay, it will take, you know, more than 1 hour and 30 minutes. Okay, if you are professional in it. Okay, otherwise it will take, you know, 80% of your project time. Let's say, you know, there is a, you know, project time 30 days, so it will take around, you know, 24 days, I guess. Okay, to clean your data, just to clean your data, nothing else. Okay, what about else? Okay, let's go ahead and use all the, you know, data over here, remaining columns. As we know, hp is there, plus volume is there, plus speed is there, plus weight is there, right? And my data is going to be the wcat. Okay, not the wcat, is going to be the cars, right? And after this, let's go and run this. Here you can see my model is complete, and let's see the my model. Okay, model dot params. Okay, these are the parameters now. Okay, now my model is not the just two coefficient. Now model has the, you know, five coefficients. First intercept, then beta 1, beta 2, beta 3, and beta 4. So you can see over here. Okay, as I told you, the, you know, this thing. Okay, y equal to beta naught plus beta 1 x1 plus beta 2 x2 up to so on beta n xn. That's what, okay, we can see over here: beta naught, beta 1, beta 2, beta 3, beta 4, and these are nothing but the x1, x2, x3, x4, right? So these are the different things you can see over here. Now guys, okay, this is the thing. Now let me go with the summary. Okay, the model dot summary. Okay, and summary is the, you know, method, so that's why I have to go with the the brackets. Okay, round brackets. Now here you can see, now again I got the same output, okay, the same summary. Okay, I got the dependent variable, which is nothing but the miles per gallon. My model is ordinal least square. My method is least square method. When we executed my model, okay, at this date, at this time, how many observations are there? Okay, 81 observation. Degrees of freedom for the residual, which is nothing but degrees of freedom for the error. Okay, degrees of freedom for the model. You can see now the 4 degrees of freedom here, because you will see that the you just created the 5 parameters, okay, and total parameters minus one is going to be your degrees of freedom for the model. Let us talk about the different evaluation matrices you're gonna use. Okay, so simply here you can see that just by using the 82 observations, you can see total data points are nothing but the 81 number of data, number of observations or number of rows are there, total 81 are there, right? So just by using 81 rows and how many columns, here you can see only 5 columns, and out of 5 column, one column is the target column. So except this column, only 4 column is there. So with the help of this 4 column, okay, we can build the model which can predict the mpg, mile per gallon. Degrees of freedom for the residual is, again, I told you that it's a statistical term. Okay, to explain this particular term, again we need to again a lot of time to understand this term, because it's a very deep meaning term. Okay, just from from the you can just try to understand this, not the deeper, just overall, I can say it's a degrees of freedom for the error. Okay, degrees of freedom for the error. And the degrees of freedom for the error is nothing but the total observation minus your number of parameters you wanna just create, you wanna estimate in your model. So here you can see I just estimated total 5 parameters, right? Beta naught, beta 1, beta 2, beta 3, beta 4, to total 5 parameters are there. And total how many observations are there? 81 observations. So 81 minus 5 parameter, which is nothing but the 76. This is the degrees of freedom for the residual. Okay, degree of freedom for the, okay, so r square value here is 77.1%. Now here the interpretation of r square value is that, okay, there is 77% of variation or percent of information of mpg, miles per gallon column, which is explained by these remaining columns, which are nothing but the horsepower, volume, speed and weight. Got it? Okay, which means that, okay, this model is again, you know again you can say that the somewhat, again the powerful model. Okay, again here also you can make the changes in your model, so it can increase the r square value, so automatically the remaining values will also increase, except these three it will reduce. It will definitely reduce if you go ahead and make changes which is positive changes, not the negative changes. Okay, so it's like a trial and error method. Okay, to see, okay, whether you're, if you are adding someone, okay, some new feature, so which means that it will definitely just show you the throw you the r square is, sometimes maybe higher r square, or sometimes maybe lesser r square, depending upon the power of that particular new variable. Okay, so at that time you will see that this, okay, this values will increase, and these values you will see that will decrease, will tends to zero. If your model is good, this value will be very much close to zero, let's say 20, 40, 80, like that. Okay, now it's a 3 digits value. Okay, then, okay, if your model is so strong, then you will see that the this value will be in 2 digits or either 1 digits. Okay, if the r square value is tends to 1, then you can see that your model is good, your model is strong. If you say your r square value is tends to 0, or very much close to or less than 0.6, okay, then you can say that your model is poor model. Okay, you will have to do something to make the strong model. How you can, okay, how to calculate the r square? Okay, so for calculating the R square, you need to know the sum of square due to regression, sum of square due to error, and sum of square due to total. Okay, yes, yeah, the formula for creating this 1 minus sum of square due to first regression divided by sum of square due to I guess error, right? So by using this particular formula, you can simply find out this. And now what is sum of square due to regression? What is sum of square due to error? Okay, these are the, again, the statistical term. Okay, that's what I just wanted to show you. Okay, okay, if you go into the deeper of this linear regression or the multiple linear regression, again, it will take so much time to understand this thing. You will find that these all are term. Behind this term there is one formula, and in that formula there are few terms. Okay, and again behind those terms there are few things, right? Okay, like behind RSS, residual sum of square, there is much more thing. Okay, the formula of RSS is nothing but the summation in in the bracket. You will find that the your values minus that estimated values. Okay, the estimated, which means the error. Okay, your original value and your estimated value, and bracket square, like that. Okay, and divided by divided by 1 divided by n minus 1. Okay, so this is the thing, this is just the formula for the residual sum of square, right? So like that, if now, okay, you will have to understand what is x and what is x hat. Okay, right, these are the estimated values, I can say. Okay, x hat, y hat, in terms of. So here you can see the HP column. Okay, okay, this is the intercept. Intercept is the coefficient value. This is not the variable. Okay, if you talk about the HP column, so here you can see, you can go over here. Okay, this is again each and every term. Okay, will have the separate meaning, guys. Okay, will have the separate meaning. This is the coefficient, which is nothing but the beta 1 value. Okay, this is the standard error for this particular column. Okay, HP column, you will see that the standard error for this. Okay, this is the t test value, and this is the p value for the t test. So most of the time, okay, if you know all the thing, you can simply go ahead and you can see the p value, like I am seeing. Okay, if you know all the things, you can go ahead and see the p value, right? Because I know all the things. Okay, like the what is t value, how you can calculate the t value, what is the reason behind the t value, how you implemented t value test over here. And lastly, here you can see this is nothing but the confidence interval. Okay, like as I told you in the yesterday session. Okay, the about the confidence interval. Now let's come to the topic and see. Okay, understand. Okay, like one by one. Okay, like this HP is significant or not, volume is significant or not, like this. So here you can see HP, the p value for HP, you can see 0. And as we know, if we compare with our p value, which is the default p value, I can say, or most of the time we are using p value, which is nothing but 0.05, and the p value here is 0.000. Okay, so as we know, this p value is less than 0.05, right? So we can simply say that HP is the significant column for making a prediction, okay, of about the MPG. Okay, which means that this column is the something significant column which can make the prediction or about the MPG column, right? This is the first column we can see. Okay, what about second? This is the volume column. Okay, in the volume column you can see the p value is 0.556. So as we know, if we check with p value, which is 0.05, so here p value is higher than this, right? So here our p value, the default p value is 0.05, but our p value, which is this 0.556, which is greater than 0.05, which means that this particular column is insignificant column. This volume column is not contributing, okay, in our model to make the prediction about MPG column. Now this is the insignificant column. In the same way, okay, if we check for the SP column, so you can see 0.015. Okay, again we can say that if we compare with our p value 0.05, so this value 0.015 is less than 0.05. Yes, so this is again the significant column, I can say. Understood? What about weight column? So weight column here, the p value is 0.814. So here you can see, okay, the p value for the weight column is 0.814, which is greater than 0.05, which is the default value of p value. Okay, or most of the time we are using this. Okay, so if the p value is greater than 0.05, so in our case this is greater than 0.814, which is greater than 0.05, right? So again, this column is also insignificant column. This column is not contributing to make the prediction about the mpg, right? So out of 4 column, okay, 2 columns are the insignificant columns, which means these 2 column, volume and weight, which are not contributing in our model. And these 2 columns, okay, the hp and speed column, are contributing positively, right? Contributing very strongly to make the prediction about the mpg column, and that prediction is correct. And these 2 columns are contributing negatively, in negative direction. Understood? So that is the thing. So that's how you can find out which column is, contributing in your model and which column is not contributing. So that is about the multiple linear regression, guys. Okay, as we saw the simple linear regression and multiple linear regression, we also saw the evaluation matrices. What are the different evaluation matrices are there? What is the r square? Okay, what is the different evaluation matrices? Adjusted r square, f statistics, and remaining all this. Okay, there are, okay, there are lot, right? There are lot. Okay, just the thing is that you will have to explore it, right? You will have to explore it. Okay, and for that, like I created a one course, which is, I guess, around more than 120 hours of course, I guess. And in that course, okay, I'll be trying to explore in very much more deeper. So each and every concept will be clear, like that. That's it about the session, guys. Thank you, guys. Thank you very much for being with me, and thank you very much. Bye bye.